In this video, I'm going to go through the 2020 question 1 on Leaving Certificate Chemistry. As always, this is a titration question. The question starts by saying washing soda is a cheap household chemical used for laundry, removing grease and softening water. Washing soda crystals are hydrated sodium carbonate, Na2CO3.XH2O. The crystals, effluents, which means they lose some water of crystallization, in dry air becoming powdery in the process. To determine the average value of X in the formula Na2CO3.XH2O for a sample of washing soda, 3.46 grams of the crystals were dissolved in deionized water and made up to exactly 250 centimeters cubed of solution. 25 centimeters cube volumes of this solution were pipetted into a conical flask and titrated with a previously standardized hydrochloric acid solution using a suitable indicator. The balanced equation for the titration reaction is 2HCl goes to Na2CO3 goes to 2NaCl plus H2O plus CO2. This is, as I hope you can notice, a washing soda crystal titration. The main thing about this is the only part of the crystal that reacts in this titration is the sodium carbonate, the Na2CO3. The .XH2O does not react. In this, it says identify a primary standard that could have been used to standardize hydrochloric acid solution for this analysis. The answer for this that you could use is sodium carbonate. However, it's not the sodium carbonate that we're using in this particular experiment. It's the sodium carbonate that's anhydrous. That means it doesn't contain any water. In part B, it says describe how the 250 centimeter cube solution of washing soda was prepared, starting with 3.46 grams of washing soda measured out accurately on a weighing boat. To begin here, you would transfer to beaker and the rinsings. Then what you would do is you would dissolve crystals in a minimum of deionized water. Here I'm writing DIW. However, in the exam you should write deionized water. Then, using a funnel, you're going to transfer the solution from beaker to volumetric flask, and I'm just writing VF. However, in the exam you should write volumetric flask and add rinsings too. Next, you make up the volumetric flask to the mark using deionized water. As you're doing that, you need to make sure you add the last few centimeters cubed, drop by drop, using a dropper or a dropping pipette, and the bottom of the meniscus is on the mark. And it has to be at eye level. And then finally, stopper and invert 20 times. C part I says name a suitable indicator for this titration. You would use methyl orange. It says justify your choice of indicator. This isn't necessarily a titration question. This is a pH and indicators question. However, the reason why we use this is because it is a strong acid weak base titration. This will become clearer as you're doing pHs and indicators later in the year. Using this indicator, what colour change was observed in the conical flask at the end point? And what you should have seen is it went from orange to pink. The next part is all about the calculations, and to fit the calculations in, I'm just going to remove the answer for part B. Part D starts by saying on average 21.5 centimetres cubed of 0.12 molar hydrochloric acid solution were required to completely neutralise 25 centimetres cubed of washing soda solution. Find by calculation the average number of moles of HCl used up in this titration. Therefore, we're starting with hydrochloric acid. In terms of the hydrochloric acid, it says that we have a 0.12 molar solution. That means that we have 0.12 moles in 1,000 centimetres cubed. However, we didn't use 1,000 centimetres cubed of hydrochloric acid. It said that on average there was 21.5 centimetres cubed of it used. To figure out how many moles were in that 21.5, I'm going to divide by 1,000 to figure out how many are in 1 centimetre cubed, and then multiply by 21.5 to figure out how much moles are in 21.5 centimetres cubed. Dividing by 1,000, we'll add 3 zeros. And then multiplying by 21.5, I get an answer of 0.00258 moles. So therefore, in terms of the hydrochloric acid, there was 0.00258 moles added to the conical flask on average for each titration. In the second part, it says the number of moles of Na2CO3 neutralised in each titration. Looking at the chemical equation, it's 2HCl reacting with 1 Na2CO3. We've just figured out that we had 0.00258 moles of hydrochloric acid being added into the conical flask each time. That would have reacted with half the amount of moles of Na2CO3. 0.00258 divided by 2 gives us 0.00129 moles. Therefore, 0.00129 moles of Na2CO3 were in the conical flask. The next question says, the number of moles of Na2CO3 in 250 centimetres cubed of the washing soda solution. It said in this one that 21.5 centimetres cubed of the 0.12 molar hydrochloric acid solution were required to completely neutralise 25 centimetres cubed of the washing soda solution. Therefore, there was 25 centimetres cubed of the washing soda placed into the conical flask. We know of that 25 centimetres cubed that 0.00129 moles of it were sodium carbonate. So that 25 centimetre cubed was equal to 0.00129 moles of sodium carbonate. To figure out exactly how much was in 250 centimetres cubed, we just need to multiply by 10, as 25 by 10 will give us 250 centimetres cubed. So we'll have 0.0129 moles of sodium carbonate were in 250 centimetres cubed. In part 4, it wants us to calculate the mass of the Na2CO3 in 250 centimetres cubed of the washing soda solution. To calculate mass, we use number of moles is equal to grams divided by mor. We can manipulate this to have a grams is equal to number of moles times the mor to calculate the mass. The number of moles here, we have 0.0129. And for the mor, we're using sodium carbonate, which is Na2CO3. So that will be 2 times 23 plus 12 plus 3 times 16. That will give us a relative molecular mass of 106 grams per mole. To calculate the grams then, we have 0.0129 multiplied by 106. So in terms of the grams, we will have 1.367. So that means we have 1.367 grams of Na2CO3 in 250 centimeters cubed. In part 5, it asks us to calculate the mass of the water of crystallization and hence the number of moles of water in 3.46 grams of the crystals. So the crystals are Na2CO3.XH2O. Some of the crystals is made up of sodium carbonate and some of the crystal is made up of water. The entire thing is 3.46 grams. 1.367 grams are sodium carbonate. So that means we can work out how much of it grams was water. And if we go 3.46 and we take away 1.367 grams, that will give us the grams of water, which is 2.093 grams. It also wants the number of moles, and remember number of moles is equal to grams divided by mOr. Well, we have the grams, it is 2.093, and the mOr, well, for water we have H2O, and that is 2 times 1 plus 16, which gives us 18 grams per mole. In terms of the number of moles then, we get 2.093 and we divide that by 18 and we'll get that the number of moles here is 0.116 moles. The last section here is part VI and it says, find by calculation the ratio of moles of water of crystallization to moles of Na2CO3 in the crystals and hence the value of X to the nearest whole number. For this, I just need a little bit more space, so I'm going to get rid of the answer for the first two parts of D, and I'm going to get rid of the other theory as well. So to go back to what we had, so we know that the entire thing is Na2CO3.XH2O. That's split up into Na2CO3 and H2O. In terms of the Na2CO3, well, we know that there's 1.367 grams, and in terms of the water, we have 2.093 grams. That 2.093 grams, we figured out in the last part, it was 0.116 moles. And we'd already calculated the number of moles of the sodium carbonate, which was 0.0129 moles. We then just need to figure out the ratio of this. So we put them together as a ratio. So 0.0129 is to 0.116. And we divide by the smallest number. And the smallest number here is the 0.0129. So that will give us 1 is 2. And then in your calculator, dividing 0.116 by 0.0129. That will give us 8.99, which is approximately 9. So therefore, the formula is Na2CO3.9H2O. So technically the X here is 9. That brings us then to the end of this video, which is going through the 2020 question 1 on Leaving Certificate Chemistry, which is all about finding or determining the average value of X in Na2CO3.XH2O, which are washing soda crystals.